As we saw in the first part of this series, if we had a parameter value of 0.5 for the binomial distribution helping us to decide whether a ball goes left or right when it hits a peg, we expect a Gaussian distribution to form at the base of the Galton box. What if we had a distribution that looks like this instead? Such a distribution would make us suspect that we had a parameter value that is different from 0.5. How do we find out the value of this parameter? We would apply the Bayes theorem, except instead of using a deck of cards, we think of the theorem in this way. We want to get the probability of the parameter values given the data we have. The probability of the data is simply a constant, and we typically ignore it and think of the probability of the parameter value given the data as proportional to everything on the right side of the equation. This term is called a prior. It is simply a first guess at the parameter value without taking the data into account. This term is the likelihood. The way to think about the likelihood is to look at the data we have and ask, what are the chances of getting these data given different possible values for the parameter theta? R computes the likelihood of different values of theta. The highest likelihood, that is the value of theta most likely to have generated the data for our Galton box, is 0.7. Essentially, this is how we derive our models in this course. We start out with the data. We then look for the linear function, the probability, and the parameter values that best conform to the data. We'll go through some code to see how we can use R to accomplish this.